All right, this is another variation problem, but we're just going to use the product and quotient rules here. So we're just not actually given functions, we're given the graphs of the functions now. So, but we're defining h of x to be the product again. And so h prime of 2, we're just going to apply the product rule. So it's a derivative of the first, but it's evaluated at 2, times the second, evaluated at 2, plus the first, evaluated at 2, times the derivative of the second, evaluated at 2. Okay. Now, we just need to figure out what those values are now, and we can use the graph to figure that out. So we can see that at 2, we have this point right here on f of x. So that's 2 comma 4, right? You can also see that the slope of this function here, it looks like the rise over run. If we go rise over run, it's up to and over 1, so it looks like the slope is equal to 2. All right, up here it looks like the slope is equal to 0, just in case we need that. Slope of g of x looks like it's a minus 1. Minus 1. And we can also get the value of g of 2, right? Because we come up here and we have this point 2 comma 6. Okay, so I think that's basically all we need. So the first thing we need is the derivative of f at 2. Okay, so the derivative is the slope, and you can see that the derivative of f of x at 2 is just going to be this 2, right? Because the slope of the line is 2. So this value here is just 2. G of 2, right? So now we just need that actual value of the function, not the slope, is just 6, right? And f of 2, we figured out that that's the value of the function at 2 for f of x. So that gives us, that's 4. And now we need the slope of g, right? Because we're looking for g prime, which is the slope at 2. So it looks like the slope of g is the minus 1. Okay. Then it's just arithmetic. So we have 12, whoops, that should be minus 1. So 12 minus 4 gives us 8. So the derivative of h at 2 is 8. So the derivative of k at 6 is similar, right? It's just only k is defined as a quotient. So we're going to use the quotient rule to figure out what the derivative of k is at 6. All right, so it's low, right? So low evaluated at 6, d high, f prime evaluated at 6, minus high evaluated at 6, d low, right? So low is g. We need d low evaluated at 6. And then we're going to divide that by low squared, right? So we have g of 6 quantity squared. Okay, now we just need to find those values. So, all right, so I need to come over here, and what is g at 6? So when x is 6, g appears to be 2. So I'm going to put that value in. The slope of f at 6 appears to be 0. So we'll multiply that by 0. The value of f of x at 6 appears to be 8. Right? That point is 6 comma 8. I should probably mark this one too. This is 6 comma 2. And then the value of the slope of g of x at 6 is just minus 1 again. And then we need to divide that by the value of the function g of x at 6. So that gives us 2. And we need to square it. All right. So this first thing is just 0. So we have minus 8 times a minus 1, which is just 8. And then the denominator is 2 squared, which is 4. So that just is 2. And there you go. All right, that's all the examples I have for this lecture, and I will meet you, I will see you in class.